Hi, my name is Logan Hubler, and this is the interactive advanced concept presentation number 6, the nuclear bomb. For this week's module pertaining to nuclear chemistry, we cannot perform an experiment because nuclear chemistry is not as easy or as safe to perform at home. So instead of demonstrating my experiment, I'm just going to be doing a presentation on nuclear chemistry and the nuclear bomb. So first, some background information. There is a key problem, which is separating two nearly identical variants of the element uranium. Natural uranium occurs as a metal, and it contains two isotopes. Most uranium is U-238, but U-235 can sustain a chain reaction, while U-238 will not. So in other words, uranium-235 is usually what's used in the nuclear bomb because it can sustain that chain reaction, while U-238 cannot. The two major uranium isotopes have identical chemical and magnetic properties. So it can be very difficult to separate them because they are identical in chemical and magnetic properties. The only small difference is that uranium-235 weighs just a little bit less than uranium-238, which makes the separation possible. So due to the fact that there is a difference in weight, uranium-235 is slightly less than uranium-238. It makes separation of the two isotopes possible. When the two isotopes are exposed to an equal force, they will move at different speeds, and they will move at different speeds due to the different weights. There are many components necessary to achieve the chain reaction required for nuclear fusion. Fusion requires both extremely high temperatures to give hydrogen atoms enough energy to overcome repulsion between the two protons. Energy from things such as lasers or microwaves must be used to heat hydrogen atoms to necessary temperatures. Again, the temperatures need to be very, very high so the hydrogen atoms have enough energy to overcome the repulsion between the protons. Fusion requires temperatures about 100 million Kelvin. Now that is very hot. That is approximately 6 times hotter than the sun's core. At temperatures this high, hydrogen is not a gas, rather it is a plasma. So you need to get hydrogen hot enough so it becomes a plasma rather than a gas. So about 100 million Kelvin. That is very hot. Nuclear fusion is a type of nuclear reaction where two light nuclei collide together to form a single heavier nucleus. Fusion results in a release of energy because the mass of the new nuclei is less than the sum of the original masses. So again, fusion releases energy, and fusion is a type of nuclear reaction where two nuclei collide to form a heavier nucleus. So, an explanation of why the bomb occurs, of why the nuclear bomb occurs. A nuclear explosion is an explosion that happens as a result of the rapid release of energy from a high-speed nuclear reaction. Nuclear bombs are made up of fissile elements such as uranium, as I stated earlier, the uranium-235 and uranium-238, which is enriched in the isotope that can sustain a fusion nuclear reaction. When a free neutron hits the nucleus of a fissile atom, like uranium-235, as I stated, the uranium splits into two smaller atoms called fission fragments and more neutrons. So the split causes the two smaller atoms called fission fragments and also more neutrons. Now, when a uranium-235 atom absorbs a neutron and fissions into two atoms, it releases 3 neutrons and some binding energy, which causes a nuclear chain reaction. 2 of the 3 neutrons do not continue the reaction because they are lost or absorbed by a uranium-238 atom. Only 1 of the 3 neutrons does collide with an atom of uranium-235, which then fissions and releases 2 neutrons and some binding energy, as I stated earlier. Both of those neutrons collide with the uranium-235 atoms, each of which fission and release between 1 and 3 neutrons, and so on. This then causes a nuclear chain reaction in the nuclear bomb explosion. In terms of the actual nuclear bomb and the actual nuclear explosion, the actual nuclear explosion takes place in a few microseconds. The radiation lasts a few milliseconds, except for the residual radiation and materials irradiated that will last for years. The rest is all plasma superheating the atmosphere to produce the blast effect. That is all, and that is why the nuclear bomb occurs. Thank you for watching.